All right, IM3 classes. Today we're continuing on with our graphing. We're going to look at specifically quadratic functions, characteristics of quadratic functions. What we're going to be doing today is finding the vertex, basically what we're going to be doing, and the axis of symmetry. And we're going to be determining minimum or maximum values. So we're going to be using this formula right here, negative b over 2a. The b and the a come from the general form of the equation, ax squared plus bx plus c, where the a is always attached to x squared, the b is always attached to x. We use that. That's going to be the axis of symmetry, where the graph is symmetric, and then we plug that back into the formula to find the y value for the vertex. We tell if it is a minimum or maximum. So let's look. So we're going to find the minimum or maximum value of f of x equals 1/2 x squared minus 2x minus 1. Describe the domain and range of the function. The domain is increasing and decreasing. So let's go through. First, I'm going to rewrite this. I'm just going to use y because I don't want to write f of x. So 1/2 x minus 2x minus 1. So first thing we're going to do, we're going to find that minimum value. It's going to be x is equal to negative b over 2a. Our a and b come from this. So this is a, b, and c. All right, that comes from the general form of the equation where it's ax squared minus bx minus c. So a, b, and c. So for this x value, it's going to be negative b. And so when we put in this negative here, all right, this negative belongs to the 2. So our b value, right, is negative 2. So it's going to be a negative, negative 2. Oh, wrong thing. So negative 2. And then the a value comes from what's in front there. He's green. So this is the a value right here. So that's going to go in here. So a is 1/2. Again, messed up. So negative 2 is a positive 2. 2 times 1/2 is 1. So this all simplifies to x equals 2 is our value here. So this is going to be a minimum value. What we want to look at is our general equation. Let me go back a slide. Our general equation, it's going to open up when this first a value is positive. So that means it opens up this value here, the x value, that is going to be a minimum. If the a value is negative, that means it opens going down. That means that this is the a value is negative. So this is a minimum value. The domain and range of the function. So since this is a minimum, the domain, actually, for all these, for quadratics, the domain can be all real numbers. So we're going to use inequality notation. So the x's can go from negative infinity to positive infinity. The range, since this is a minimum value here, we need to find the y values that it cannot go below. So what we need to do is plug this back in to the equation. So, man, I'm getting sloppy here. Y equals 1/2 x squared minus 2x minus 1. This 2 is going to go into the x squared and the x here. We're going to replace those. So it's going to be 1/2 times x squared minus 2x minus 1. Put the 2 in there. So 1/2. So 2 squared is 4. Oh, forgot to put the 2 there. Minus 4. 2 times 2 is 4. Minus 1. So 1/2 of 4, that's going to be 2. Minus 4 minus 1. 2 minus 4 is negative 2, minus 1 is negative 3. So y, when x is 2, y is negative 3. This would also be the vertex of our formula. So the vertex is at the point 2, negative 3. All right. And so the range, our y values, since this is a minimum, it's not going to go below negative 3. So the y can be at negative 3 to infinity. So it's going to look like that. All right. And then the function is decreasing. Yeah, we're going to skip the increase and decrease part. Let's just move on. So find the minimum maximum value. Let's do this. Let's just go on to graphing. So this video isn't an hour long. We're going to graph. We're going to label the vertex and axis of symmetry. So we're just going to find two things. The first thing we need to do is find the negative b over 2a. So remember, this is a, b, and c. So our gonna put in negative b over 2a. B, again, be careful with the b. When there's a negative here, that is b is negative 6. So I'm going to put in negative 6 for b, and a is positive 3. Just highlight some things again. So a is positive 3, so that's going in here. Multiply or simplify that. Okay. All right, so negative 6 is positive 6. 2 times 3 is 6. 6 over 6 is 1. So x is 1. Let's put that back into the formula. So y is equal to 3x squared minus 6x plus 1. So my x equals 1 is going to get, I'm going to substitute in for the x squared there and the x there. So it's going to be 3 times 1 squared minus 6 times 1 plus 1, and put in 1 for those x's. So 1 squared is 1, so this is 3 times 1 is 3, minus 6 times 1 is 6, plus 1. 3 minus 6 is negative 3, plus 1 is negative 2. So that's our y value. So our vertex is at the point 1, negative 2. So let's plot this point. The vertex 1, negative 2 is right here. Okay, not what I wanted, stupid board. So 1, negative 2. X equals 1. This is the axis of symmetry. So the axis of symmetry goes through the vertex. So let me change the color of my pen. I'm going to put in the axis of symmetry as a dotted line through the vertex. And so we are just going to sketch this out. This is as accurate as we need to be for this. And then I'm actually going to do the graph in purple. Just feel like doing purple. Since this is the vertex, this is positive, so that means it's going to open up. So it's going to look like this. Let's do one more with a negative, hopefully. Here we go. One more with a negative. I'm going to do the same thing. I need to find my x value for the vertex or axis of symmetry. That's going to be negative b over 2a. So negative b over 2a. So this is a, this is b, this is c. B on top is a negative 8. Remember, that negative belongs to 8. So negative a on top. The a on bottom, that's a negative 2. So negative 2 on bottom. So negative 8 is a positive 8. 2 times negative 2 is negative 4. 8 divided by negative 4 is negative 2. All right, so this is the x value. This is also the axis of symmetry, AOS. I'm just gonna shorthand that, axis of symmetry right there. I need to find the y value of my vertex now. And again, to find the y value, you take your x you just found, that axis of symmetry, and it's going to get put in for the x's here. So it's going to be -2 times 8x plus 1. So x is -2. And then -2. We got a lot of negatives here, so we got to be careful. So -2 squared is +4 minus 8 times -2 plus 1. -2 times 4 is -8. Careful here. This 8, you can change it to, it's a -8. We can do plus a -8, but it's -8 times -2. This is going to make this a +16. Be careful with the negatives there. Plus 1. -8 plus 16 is +8. Plus 1 is +9. So nope, that's not x. This is the y value. So y is equal to +9. And so our vertex is going to be at -2, 9. So I'm going to go -2 up 9. That's going to be here. This is, I put it, oh, there we go. All right. And then the axis of symmetry is through that. So it's just a straight line at x equals -2. All right. And now the graph. Since this is negative, and again, I wasn't sure if it was clear on the other ones, we're looking at this negative here. Since it's the A is negative, this opens going down. This is so this is opening going down. It's going to look like this. Again, we don't need to be any more accurate than this frame. We use the vertex, axis of symmetry. Does it open up or down? That's what I'm going to be looking for. So again, here, if we look at the 3 is positive, that's why it opens up. We look at that. The first term is positive or negative. That's going to tell you if it opens up or down. And that will do it for our lesson. Next time, we're going to be getting into adding and subtracting polynomials.